Computational Social Science, CSS, is an emerging field that combines computational methods with social sciences to better understand complex social phenomena. By leveraging big data, machine learning, and advanced analytics, CSS is transforming research and providing new ways to tackle the big societal challenges. As a sociologist, I find that CSS is revolutionizing sociology by offering powerful tools to analyze intricate social dynamics. CSS helps us to understand population changes, such as migration, and it uncovers patterns of social inequality by harnessing new types of data, such as from mobile phone records to job description ads, and applying machine learning to more accurately predict better social outcomes. This enables sociologists to ask deeper questions and support evidence-based policies aimed at creating more equitable societies. While CSS is becoming increasingly essential to research in sociology, let's now explore how it is shaping the future of social sciences research across other disciplines.
My research combines advanced geospatial data science and CSS, focusing on satellite image fusion and spatial-temporal analytics for environmental and health assessment. By integrating computational tools with geospatial data, my work captures both physical changes and the social forces shaping urban spaces. I'm particularly excited about machine learning-powered causal inference and agent-based modeling, which offer policymakers evidence-based insights for more inclusive and sustainable cities.
My research explores how changes in city environments, like rising temperatures or air pollution, impact people's everyday activities, especially in vulnerable neighborhoods. By integrating satellite heat maps with mobility or social media data, we can see how extreme heat influences daily routines in low-income areas. Ultimately, these insights help cities create smarter and more equitable policies, like targeting pollution reduction or urban greening, so climate adaptation reaches everyone, not just a few.
I use causal inference methods to investigate social equity issues in public sector employment, climate policy, and digital governance. By using big data methods to analyze large administrative and policy datasets, I can identify how institutions either reinforce or reduce these gaps. I believe this approach can provide a more accurate picture of social inequalities and instruct policymakers to develop fairer and more effective policy interventions.
In the past decade, large-scale cognitive and neuroscience datasets have emerged, allowing data-driven approaches using foundation models to uncover subtle trends in human cognitive processing. Beyond helping us better understand the brain, we've also found that as AI gets better and better, it starts to behave more like humans and mirrors brain representations. With more data and smarter AI, using computational methods to analyze and respond to these trends is becoming essential.
My interest lies in the interdisciplinary fields of CSS and science of science. I use large-scale datasets from the real world and develop computational tools to study complex social and economic systems. Specifically, I study AI for science, focusing on its research benefits. I examine how science interacts with society and contributes to human well-being, and study the behavioral dynamics of researchers and how education in training the future generation of scientists.
CSS has become essential for investigating digital social media data, complex networks, and uncovering previously inaccessible patterns. Incorporating big data analytics, network analysis, natural language processing, and agent-based modeling has advanced the field. New tools like generative AI automate data tasks, while causal inference address cause and effect questions, enabling cross-disciplinary research and evidence-based policy making.
My research looks at how emerging technologies like social media and AI shape the way we understand politics, news, and society. I use CSS to analyze large-scale data, uncover patterns, and ask critical questions. I'm interested in how different AI systems recommend and frame news, and what that means for public knowledge and trust. Computational methods help us study these systems in depth and push for greater transparency, accountability, and equity in how they are built and used.
As you have heard about the different research areas and perspectives from our members, CSS is a truly interdisciplinary field with applications spanning migration studies, social inequality, public health, urban planning, and beyond. If this has piqued your interest, we encourage you to delve deeper into CSS and connect with our faculty members. They are eager to collaborate and share their expertise. Looking ahead, CSS holds tremendous potential to transform both academia and society. Here at our faculty, we are fully committed to advancing this dynamic field and driving meaningful social change.